China makes most of the world's battery cells, and while production concentrated there, battery pack prices collapsed. Adjusted to $2025 dollars, they fell from $827 per kilowatt hour in 2013 to $108 in 2025. So what did China actually build, and can the West catch up without becoming even more dependent on it? April 2026, CATL Tech Day in Beijing. CATL announced the third-generation Shenxing battery. It charges 10 to 80% in 3 minutes 44 seconds, 10 to 98% in 6 minutes and 27 seconds. These numbers shocked the world. Its rival, BYD's Blade 2.0, does 10 to 70 in 5 minutes, at up to 1.5 megawatts of power. These two companies are racing each other, but physics always charges a price. Pushing that much current risks lithium plating, metallic lithium crusting onto the anode instead of slipping inside it. Get it wrong and you grow dendrites, microscopic metal needles that can pierce the separator. But CATL says its design targets less heat generation, stronger thermal propagation resistance, and more precise control. So the real challenge is not just charging fast, it is keeping the cell stable while doing it. Here's a different question. Can a cheaper chemistry change the factory equation? Sodium sits directly below lithium in the periodic table. These are two alternative cell chemistries, one lithium-ion cell and one sodium-ion cell. Sodium is abundant. It is part of ordinary table salt, but the trade-off is energy density. That means a battery of the same weight stores less energy and gives an EV less range. CATL and Chang'an introduced a sodium-ion passenger vehicle program in February 2026. Naxtra reaches up to 175 watt-hours per kilogram. That number means how much energy a kilogram of battery can carry. It can operate from -40 to +70 Celsius and can exceed 10,000 cycles. The clearest uses are short-range urban EVs, grid battery storage, and cold weather operation. Sodium can reduce reliance on lithium, but it does not automatically create an independent battery industry. The final question is this: can this chemistry be made at scale outside China? This one is solid state. In a conventional cell, a liquid electrolyte carries charge between the electrodes. A solid-state cell replaces that liquid with a solid layer. The promise is more energy in the same space. The hard part is making that layer reliably again and again on a factory line. The path is not a staircase, it is a chain. Laboratory cell, pilot line, vehicle test, then repeatable factory output. Developers in China, Europe, and the United States are working through those stages. The race is open because no one has yet proved mass production at the scale that changes car prices. Europe did not lack ambition. Northvolt was built to turn that ambition into operating battery factories. Its flagship plant had 16 gigawatt-hours a year of installed capacity, the equipment that could be run, not proof of cells leaving the line. A battery factory only works when every process works together. Materials arrive, machines run in sequence, cells pass quality checks, finished packs leave on time. When output did not arrive as promised, BMW canceled a €2 billion order. The canceled order did not cause the production problem, it exposed it. Northvolt went bankrupt in March 2025. The lesson is not that Europe cannot build factories, it is that owning machines is different from knowing how to operate a high-yield battery line every day. The United States chose a different tool: support for every cell made at home. Korean and Japanese manufacturers invested in American plants. Panasonic's Kansas plant is running. but consumer EV credits ended in September 2025, and Ford chose to license CATL technology. Europe still has CARTs, silicon anode manufacturing, Verkor, Volkswagen's PowerCo, and binding battery recovery targets. The United States and Europe are present. The unanswered question is whether they can turn those pieces into reliable output before the gap becomes permanent. The price story has two sides. Competition, manufacturing efficiency, and lower-cost LFP battery packs helped bring the global average lithium-ion battery pack price down to $108 per kilowatt-hour in 2025. Cheaper batteries can lower the cost of electric vehicles and grid battery storage. But price leadership and a healthy supply chain are not the same thing. Intense competition has squeezed margins, leaving many suppliers under pressure. China also reduced the export VAT rebate on battery products from 9% to 6%. A VAT rebate lets an exporter recover eligible VAT, reducing the tax embedded in the exported product. Cutting it makes exported batteries less profitable. The policy is scheduled to end on January 1, 2027. So the real question is not simply who makes the most cells, it is whether more countries can build a resilient supply chain that keeps learning, producing, and improving. China leads in production scale, LFP supply, midstream materials, and pack cost. The United States has silicon anode manufacturing capability and public financing. The European Union has binding battery recovery targets. Solid state remains an open race. The answer to the whole film is this. China's cost lead comes from chemistry choices, scale, and operating experience. Copying one battery is not enough. The hard part is making millions reliably, high yield, consistent quality, high throughput, repeated across factories. The West will need both, selected technology licensing to move faster, and long-term capability building to become less dependent.